Hey, this is Hussein from EJ Academy. I'm back with another video. This video is about compounding period. In the previous video, we talked about simple interest versus compound interest. In this video, we wanted to go deeper into compound interest and talk about compounding period. We have different options here. Some accounts compound the interest every year, and some other accounts compound interest every quarter of a year, or they do it monthly. So we wanted to compare this type of compounding period. Let's just start with the type of interest that is compounded annually. Let me draw a timeline here. For the purpose of this video, let's assume the principal or the original money that you invest in the account is $100, and the interest rate is 5% or 0.05, and this is compounded annually. So we wanted to see after year one how much is the balance of the account. So the total money in the account, let's use F for that. F is equal to the principal plus the interest that is applied to the principal. So the interest is 5% times P. So this part here is the interest. And we can simplify this and we get P times 1 plus 0.05. If we fast forward to year 10, for example, what we have in the account after 10 years is the principal times 1 plus 0.05, which is the interest to the tenths. This is what we saw in the previous video. If we replace P with $100 and do the math and simplify, we will get $162.89. So this is not new. This is what we reviewed in the previous video. Let's move on to the second example, which is about an account that pays interest which is compounded quarterly as opposed to annually. So in this account, interest is compounded quarterly. Let me draw my timeline again. At the beginning, what we have in the account is the principal of $100, and the interest rate of this account is the same as the previous example, 5%, but it is compounded quarterly. So in this account, since the interest is compounded quarterly, every quarter the balance will change. So instead of jumping to the end of the first year, we have to calculate the balance of the account every 3 months or a quarter of the year. So after the first quarter, so this is end of first quarter, we have to calculate the balance. So the balance F is equal to P, the principal, plus the interest. What's interesting here is that this interest rate is annual interest rate, which is compounded quarterly. And we have to change it to quarter interest rate. Quarter interest rate, which is I divided by 4 or 0.05 divided by 4. because 5% is what is paid to the account for the whole year. And since right now we're interested to calculate the interest that is paid to the account after 3 months, so we have to divide what is paid to the account for the whole year by 4 to get the interest for the end of the first quarter. So getting back to the equation, F is equal to P plus 0.05 divided by 4 times the balance of the account, which is the principal P. And if we simplify, we would get P times 1 plus 0.05 divided by 4. So basically, at the end of the first quarter, what we have in the account is this money right here. Moving on to the end of the second quarter, Q2, the balance of the account F is equal to what was in the account at the end of the first quarter, let's call it Q1, plus the interest, which is 0.05 divided by 4, applies to the balance of the account at the end of the first quarter, Q1. And we can simplify this equation, and we get Q1 times 1 plus 0.05 divided by 4. And we can replace Q1 with what we obtained up here. So we would get P times 1 plus 0.05 divided by 4 times 1 plus 0.05 divided by 4. And after further simplification, we would get P times 1 plus 0.05 divided by 4 to the second. Here I wanted to draw your attention to the power that we got here. So we're at the end of the second quarter, and we got a power of 2 here. Let's move on to the end of the third quarter. At the end of the third quarter, the balance would be equal to the balance of the account at the end of the second quarter, Q2, plus the interest, which is 0.05 divided by 4 times the balance at the end of the second quarter, which is Q2. And we can simplify this. We would get Q2 times 1 plus 0.05 divided by 4. Q2 is what we obtained up here, and we can replace Q2 with this expression right here. So if we replace Q2, we would get P times 1 plus 0.05 divided by 4 to the second times 1 plus 0.05 divided by 4. We can combine these two parentheses. We would get P times 1 plus 0.05 divided by 4 to the third. Again, we're seeing a pattern here. We're at the end of the third quarter, and we have a power of 3 here. And this is the balance in the account after the third quarter. And finally, at the end of the first year, which is end of the fourth quarter, the balance of the account is equal to the balance of the account at the end of the third quarter plus the interest added to the account, which is 0.05 divided by 4 times the balance of the account at the end of the third quarter, because this is a account with compound interest. So this part is the interest. And we can simplify this. In that case, we would get Q3 times 1 plus 0.05 divided by 4. And Q3 is this expression up here. So similar what we did for the previous quarters, we can replace Q3 with that expression, and we would get P times 1 plus 0.05 divided by 4 to the third times 1 plus 0.05 divided by 4. And finally, after simplification, we would get P times 1 plus 0.05 divided by 4 to the fourth. And again, at the end of the fourth quarter, we have a power of 4 here. And this is the balance of the account at the end of the fourth quarter. Now, instead of repeating this calculation every quarter, I want to fast forward to the end of the second year. Let me extend my timeline here. So at the end of the second year, 8 quarters passed from the beginning of the investment. So the balance of the account after 8 quarters would be P times 1 plus 0.05 divided by 4 to the 8th. And this 8th is the number of quarters passed from the beginning of investment. I can follow the same pattern and do the calculation for example, end of year 10. After 10 years, 4 times 10 quarters passed. So the balance of the account after 40 quarters is P times 1 plus 0.05 divided by 4 to the 4 times 10. And if we replace P with the $100 that we invested in the account, we would get 1 plus 0.05 divided by 4 to the 4 times 10. If you do the math, you would get $164.36. So compare this balance with $162.89, which was in the account with interest compounded annually after 10 years. It means that in case of the account with an interest that is compounded quarterly, the balance would grow faster than the account that pays interest that is compounded annually. We can go further and calculate the balance of the account after n years. So at the end of year n, the number of quarters passed is 4 times n. Quarters passed from the beginning of an investment, and the balance of the account would be P times 1 plus 0.05 divided by 4, and the power would be 4 times n. Now let's assume you have another type of account that pays interest that is compounded monthly. So we have an account with interest that is compounded monthly. At the beginning, the principal is $100 and the interest is the same as the previous examples, 5%, but this interest compounded monthly. Pay attention, this is an annual interest rate. The monthly interest rate is equal to I divided by 12, which is equal to 0.05 divided by 12. So every month, this is the interest rate that applies to the balance in the account. Since this is an account that compound interest every month, at the end of the first year, we have 12 months passed from the beginning of the investment. 12 months passed. So the balance of the account would be P, the principal, times 1 plus 0.05 divided by 12 to the 12ths. And this 0.05 divided by 12 is the monthly interest rate. And the 12 up here is the number of compounding periods passed from the beginning of our investment. And if we continue at the end of the second year, we have 12 times 2 months passed. So the balance would be P times 1 plus 0.05 divided by 12 to the 12 times 2. And again, the interest rate is the same. This is the monthly interest rate, and the power is representing the total months passed from the beginning of our investment, which is doubled after the second year. Let me extend the timeline again. So after 10 years, we have 12 times 10 months passed. So the balance would be F is equal to P times 1 plus 0.05 divided by 12 to the 12 times 10. And if I replace P with $100, I would get $164.70. For compounding quarterly, we got $164.36, and for annual compounding we got $162.89. So as you can see here, by increasing the number of compounding periods per year, the balance of the account grows faster. In general, if you have an account that has annual interest rate, of I, which is compounded M times per year, if you wanted to calculate the total balance after, let's say, n years, this is the equation you need to use. If total balance is equal to P times 1 plus I divided by M to the M times N. And this F here is the total balance after n years. P is the principal. This whole I over M ratio is the interest rate per compounding period. This compounding period might be a year or quarter of a year or a month, and this n is the number of years, and this m is the number of compounding periods per year. So if it is compounded annually, then m is equal to 1. If it is compounded quarterly, then m is equal 4. If it is compounded monthly, m is equal 12, and so on. Let's recap what we covered in this video. We reviewed several accounts that all of them pay compound interest, but the compounding period was different, and we obtained a general equation that gives us the total balance after n years. And we also learned that if the compounding period m increases, the total balance in the account also increases accordingly. And that was it for this video. If you have any questions, leave them in the comment section below this video, and I will get back to you as soon as I can. If this video helped you in any way, please hit the like button and subscribe if you enjoy our content and would like to see more.